Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be creating a volume calculator for the various objects that you see on the screen. So we can see that the cone here has got a volume of 209.4395, and if we alter the bottom radius we can see that the volume is recalculated in real time. And we can do this with any of our objects. So if we select the pyramid, straight away we get the volume for this. Once again, if we adjusted any of the sizes, that would change. Similarly with the cylinder, the sphere, cube and the torus. And if we click off all of the objects, we're told that no object is selected. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in the objects. So let's just grab a hold of a cube, a cylinder, a sphere, a cone, a pyramid, and finally a torus. And what we can do is just arrange these anywhere we like on the screen. It doesn't really matter where they go. So if we put our cube over here somewhere, our sphere can just be there. The cylinder, we can just move this somewhere over here. The cone, somewhere over here. And the pyramid, we'll just move forward. So we've got our objects and they're just randomly placed on the screen, ready for us to work with. The next thing to do is bring in a text spline, and we'll set the alignment to middle, the height 50, and when it comes to the font I'm going to reach for Lemon Milk Pro, as I so often do. So let's get a hold of that, Lemon Milk Pro. There it is. Okay, great, so we've got that, and we'll just move this somewhere up here and we'll arrange things a little bit differently. Let's have a look, see where our text is. That's the way around it is. Okay, that's fine. So we'll leave it just like that. So we've got our scene set up and ready. We'll also drop our text into an extrude and set this up. Well, the offset will make 1 and we'll leave everything else as it is. I'm not going to play around with the caps. I'm just going to leave that like that. And I'll rename this text. And in the basic tab, material, automatic, and I'll just make this yellow. And that's good. And then we'll just change our display to garage shading lines and isopalms. Fantastic. So everything is set up and ready to go. And this is as much as we need in our scene. Moving on from here, we can start thinking about working with Python. But before we go there, I'm just going to rearrange these. Doesn't really matter too much, but it's just that I'll rearrange them in an order that I think is suitable. And just leave them there. Just move that down there. Just put that cone up there. That's it. Okay, so I've got them in the order that I want them. Moving on from here then, let's just bring in a null. We'll rename it Python. And we'll give this a Python tag. So we're going to be using the tag as opposed to using the generator. Fantastic. So we'll switch to a scripting layout, click upon our Python tag, open in editor, and we are basically ready to start work. We can start by removing all of these comments, and then up here we can say import, and we'll say math because we want the math module. Great. So the first thing we need to do in the main function here is say obj for object is equal to, and it will be doc.get active object, open close. So that will pull the active object from here into the code. We can then say text is equal to doc.search object brackets, and it will be single quotes, text, close single quotes. So that will bring the object here, this extrude, into the code. We also want the text spline, so we'll say spline is equal to, and it will be doc dot search object brackets single quotes text spline close single quotes. And now that will bring this in for us too. Fantastic. So let's see where we go from here. We can say if obj is equal to none. So if none of our objects are selected, we wish something to happen. And we can say spline is equal to, or rather spline, and it will be, let's see if we get our text spline, and we bring in this text spline field. This is what we're interested in. So if we bring that in and drop it there, we can just take that away from the front of there. Just copy this and paste it into there. That's what we need to do. So spline, and it will be C4D prim text is equal to, and we can say no object selected, close single quotes. So that's fine, that's great. And that will give us a situation where if nothing is selected, then we can display that on the screen. We can then decide where we want to place it on the screen. So we'll say x is equal to 0, y is equal to 500, and z is equal to 0. We can then say vect is equal to x, y, z. And then finally text, and it will be dot set abs pos, so set absolute position, brackets vect. So if nothing is selected, if we execute that, just see where we are. Don't think we've got anything in there yet, so that's okay. There we go. Nothing is selected, and now we've got no object selected. We'll just put an exclamation mark on the end of that sentence as well and just execute that. That's better, so we've got that in there. So that first little part of it is now complete. So we know what's going to happen if we haven't got any of these selected. We're just going to get a message telling us that that's the case. Fantastic. So we can move on from here. So we can then say else. And now we can think about the rest of our algorithm here. We can then say name is equal to obj dot get name. So we're looking for the name of our currently selected object. If we just say print brackets name, we should be able to see this in action. So if we select the cube, straight away we get the cube. The sphere, we get that. The cylinder, etc. all the way through. So that is working perfectly, doing exactly what we needed to do. We can then start putting in some conditions. So we'll define the cube first. We'll work out the part of the algorithm that's going to give us the volume of the cube. So we can say if name is equal to cube, and now we want to work with our cube and decide how we're going to get the volume of it. Well, the formula for working out the volume of a cube is simply a cubed, or v is equal to a cubed, I should say. And I've put that on the screen there for you. However, if we look at our cube, we can see that we've got size x, y, and z, and they can all be different. So a cubed is no good to us really, because we don't want them all to be the same. So what we need to do is something a little bit different, and we simply need to bring in the size X here, grab a hold of the X, bring that in. So we can move this over here. And we can say X is equal to OBJ. And leave that at that. And that will give us this X value. We can then simply copy this and work out the rest of it. So we can say Y is equal to, paste this in, and then take away the X and replace it with a Y. Z is equal to, paste it in, remove the X, put a Z in there. So that brings all of this over here into the code. We can then work out our formula for the volume. So we can say volume is equal to, and it will simply be X multiplied by Y multiplied by, no, not brackets, multiplied by Z. So that's our volume formula. Now, if we just print the volume variable, just execute that, we can see that we've got a decimal point with just a 0 after it at the moment. Now, with the cube, it doesn't really matter what we do here. We're always going to get 0.0. It's perfectly good. But if we were to use one of the other objects, we'd probably get up to 10 numbers after the decimal point, which is a bit ridiculous. So in order to avoid that, I'm going to say, if we just take this away for a second, vol round is equal to, and then it will be round, because Python has a round function, so you can round numbers up or down to the nearest whole number using this round function. And then it's a case of just brackets volume, because that's the variable we're interested in rounding up or down. And if we just print vol underscore round, and just clear this out and execute, now you can see that there's no decimal point with anything after it, so we've got a whole number. Fantastic. So that's dealt with that issue for us. We can then copy this much of this line, place it down here, and we can then say is equal to, and it will be single quotes cube volume is equal to, with a space, and then we can simply say plus str for string, and it will be vol underscore round. Okay, so we've got that in there. Now let's just hit execute, see if we get anything, and straight away we've got cube volume is equal to, and it's 8 million. Exactly what we were getting in here. Fantastic. So that is all working as it needs to. Now at the moment, the cube volume is just at 0.0 on the X and the Z axes, and at 500 on the Y. We don't want that. We want it to be above the cube. So moving on from here, we can say pos is equal to obj dot get absolute position, get absolute pos, and we can just open and close our brackets. We can then say x is equal to pos dot x, y is equal to, and it will be pos dot y plus 200. And then finally z is equal to pos dot z. So we've done a vector to reals, and we've added 200 to whatever the position y of our cube will actually be. We can then say vect is equal to x comma y comma z, and finally text dot set abs pos, so set absolute position, to vect. Okay, let's just execute this and see what happens. And straight away we've got cube volume is equal to 8 million floating above the cube, and if we move the cube anywhere in the scene, we can see that the text is going to follow it. Fantastic. So that is all working fine. Now the only issue we've got is that this code will need to be repeated 6 times for the other remaining objects, or rather 5 times for the other remaining objects. We've got 6 objects in total. That's not really a good idea. So a more practical solution will be to define this as a function. So if we come up to here and we say define position, we can then place this into our function. So if we select all of this, Command X to remove it, so we'll cut and paste this into here. Don't want that like that. So we've got our code pasted into a function now. And down here we can simply say position open close. And all things being fair, this should work. And we get no object selected there, select our cube, and once again it leaps back to where it should be. Fantastic. So we've got our position code set up as a function, and it's all working as it should. Brilliant. So we can move on to our next object, and that will be our cylinder. So we can come down to here and say if name is equal to cylinder colon, and we're ready to start going again. So we can say radius is equal to, and we'll select our cylinder and our object tab. So radius is going to be equal to the radius, obviously, so we need to bring that into here. Put obj in front of this, paste it into the correct place. So we've got our cylinder's radius into the code, and we just need the height next. So we can say height is equal to, and bring in the height, and it keeps insisting on placing things where they shouldn't be, which is very annoying, but there you go. That's just the way things are at the moment. Let's take that back to there. Let's tab that back in. So obj, paste this in, remove the word cylinder, and we've got our radius and our height for our cylinder. We can then work out our volume from these. So we can say volume is equal to, and the formula for working out the volume of a cylinder is basically pi times the radius squared times the height. So it's quite a simple formula for this. So we can say volume is equal to math.pi multiplied by, and it will be math.pow brackets, and it will be radius comma 2 to give us the radius squared. That's how we do it. So it's raised to the power of 2, basically. You're raising the radius to the power of 2 by using this math.power function, or math.pow function. Okay, so we've got that in there, and then to finish it off, we simply need to multiply by height, and that's our formula. Once again, we'll say vol round is equal to round brackets volume, and then to finish off, copy our spline function here, or rather our spline line here, and we can say is equal to, and this time it will be cylinder volume is equal to, and once again plus string vol round. And to finish off, we will call position. Okay, so let's just uncheck this and select the cylinder, and we have cylinder volume is equal to, and it tells us what it is. Okay, fabulous. So we've got our cylinder in, and that's all working as we need it to. Moving on from here, we can work with our sphere. So if name is equal to sphere, and then we can move on and work with our sphere's volume. So how do we get the volume of our sphere? Well, it's V is equal to 4 divided by 3 multiplied by pi multiplied by the radius cubed on this occasion. So it's a little bit more involved, but it's not too difficult a formula to work with. So we'll select our sphere, and we've got our radius, and that's exactly what we need. And we can bring the radius of our sphere in. So we'll bring this into here. And as we did before, we can say radius is equal to obj. And we're ready to go with that. We can then say cubed is equal to, and this will be math.pow, and it will be brackets radius, comma 3. So that gives us our radius cubed. So we've got that part of our formula worked out. We can then say pi underscore cubed is equal to, and this will be cubed, so our radius cubed multiplied by, and it will be math.pi. So that gives us our next part of our formula. So we're taking our cubed radius, multiplying that by pi, which gives us our pi cubed variable. Finally, we can say volume. Let's just put a return there. Volume is equal to, and it will be pi cubed multiplied by 4 divided by 3, and that gives us our volume. So that's the way you do it. You do it in stages. Once again, we can copy our line here, paste it in here, and we can say is equal to sphere volume equals space, and once again copy our code here, paste it in, and we've got that done. Copy position, paste it in, and that should be our sphere dealt with. So if we just click off of here, select our sphere, let's see what we've got. We've got a problem. Volley round reference before. Okay, I didn't put vol round in, did I? So I just need to copy that from there, drop it under volume, and if we execute, we now get our sphere volume, and it tells us what that is. Fabulous. So that's our first 3 objects dealt with, and we can move on to our next one, which will be the pyramid. So if name is equal to pyramid, helps if you spell it correctly, and let's see where we go from here. So our pyramid, if we select it, we've got this size vector here. So we'll call this size. Let's just name this. So we'll say size is equal to, and we'll drag size in, drop it here, sort things out as we have to. So let's just remove that, paste it there, obj. So at the moment we've got a vector. We need to do a vector to reals. So x is equal to size dot x. Copy this and y and paste this in. Take away the y, or the x at the end in place of y there. Z is equal to, or rather just paste that in and say z at the end of there. So we've got a vector to reals from our size value here, our size variable here. Fantastic. So we can move on from here and work with our volume once again. Volume is equal to, so how do we work out the volume of a pyramid? Well, the volume of a pyramid is basically x multiplied by y multiplied by z, so all of the sizes divided by 3. That's all that we've got to do. So it will be x multiplied by y multiplied by z divided by 3. And that's our formula. Once again, volume round, we can copy that, paste it in here, and then paste or copy and paste this part of our spline line, and we can say pyramid volume is equal to, and once again copy this, paste it in, and we've got that done. And then it's a simple case of position, paste that, and that should be our pyramid dealt with. Let's just click off, see what we've got. Have we got anything? Okay, we just needed to put equals in there, or equal to, and if we select our pyramid, we now get our pyramid's volume in exactly the right place. Brilliant. So let's carry on. If name is equal to Torus, and let's see where we go with our torus. So we'll select it, and we've got 2 radii. So we've got ring radius here, and we've got pipe radius. Now let's look at our formula for the torus, and we can see that V is equal to pi times the radius squared. Now we've got 2 radii in there. We can see that we've got a small radius first, and that's our pipe radius. Okay, so V is equal to pi times our pipe radius squared multiplied by 2 times pi times our ring radius. So that's our formula. So it's a bit of an involved formula, this one. It's slightly bigger than the others, but then it would be because the torus is a more complicated object. So let's see how we work this out. So I'm going to say minor radius, because the minor radius is how this is usually described mathematically. So minor radius is equal to, and this will be our pipe radius actually. So we'll bring this into here, sort things out as we have to. So our minor radius is object, or is equal to OBGA, and it's primitive torus in a radius, and that is our pipe radius. We can then say major radius, major underscore radius, is equal to, and once again drag in the ring radius here. And put OBJ in front of that. So we've got our 2 radii that we can use to calculate the volume. We can then say volume is equal to, and it will be math.pi multiplied by math.pow brackets, and it will be minor radius comma 2. So that gives us pi times our minor radius squared. So the first part of our formula, and we can then say multiplied by, and it will be 2 multiplied by math.pi . 2 multiplied by math.pi, 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 multiplied by, and it will be major underscore radius and that is our formula. So we can see that it's all there. Pi times minor radius squared times 2 times pi times major radius. It's all there. Fantastic. So that's our volume calculated. Copy this, paste it in, copy this, paste it in, and it will be Torus volume equals, and it will be copy and paste this into here. That should give us that, and then we simply need position. Paste it in, just take that space out there so that everything is at the correct level. Select our torus, and we've got our torus volume as we need it to be. Great. So just to finish it off then, we need to work with our cone. So we can say if name is equal to cone, and we can then think about the cone's formula. So we can see that V is equal to pi times r squared times the height divided by 3. So that's our cone's formula. So we can say radius is equal to, and if we select our cone, we can bring in our bottom radius. Our top radius we can ignore, we don't need to worry about that. Bring in our bottom radius. So obj primitive cone b rad for bottom radius, we've got that. And then we can say height is equal to, and bring in our height, drop it in, obj, and we've got our two variables that we need to work with. We can then say volume is equal to math.pi multiplied by math.pow radius, comma 2 multiplied by height divided by 3. And that's our formula complete. Copy volume round or vol round. Copy this part of our spline line, and it will be cone volume equals, copy this, paste it in, and finally copy and paste position. And now if we select our cone, it's there, and we've completed it. And that is all you need to do to create a volume counter for these primitive objects. And it all works exactly as it should. And if you don't select any of them, it just says no object selected. And we know that we can place these objects anywhere we like in our scene, and our text will be placed with them. So yeah, it all works exactly as we need it to, and we can adjust any of them. We can do whatever we like, change the radii or if we're using a pyramid, we can change the height or either of our two size vectors there, our X and Z size vectors. But yeah, that's how you do it. And it all reacts accordingly. So yeah, it's doing exactly what we need it to do. But relatively simple code, nothing too complex about it. And it's pretty simple to achieve. But yeah, that's how you do it. I mean, if you find that you're adjusting, say, the height of this cone here, and it's going to go through your text, if you wish to, you could use this height variable here, and you may be able to create another variable from it and make the text move up and down and keep it a certain distance from the actual objects if you wish to, just by using a simple formula there. I'll leave that to you. If you want to put that in, you can. I mean, I'm not going to bother here, but you know, it does what I want it to do, and it's illustrated how you can go about making this thing for yourself. And that's all I really wanted to do within the context of this tutorial. So yeah, it's all there and it's doing what I want it to. But yeah, that's how you go about doing it. So if we just switch back to our standard layout, we've got it all there, and you can see that it all looks really nice. It's a bit of a shame that we can't work with the platonic objects. The reason for that is because if we get a platonic here, what we need is the distance. If I just zoom a little bit closer to the object, what you need is this edge here, and all of these edges are all the same length. So you just take edge A, as it's called mathematically, and you plumb that into the necessary formula. But unfortunately, with our platonic, we don't have that length. We've simply got a radius. That's all we've got to work with, and that's no good to us. So we can't work with platonic objects, unfortunately. We can only work with the 6 objects that I've placed on the screen. So that's why I haven't worked with platonics. Bit of a shame, but it's just the way it is. But anyway, there you go. That's how you go about creating a volume calculator for a cube, sphere, cylinder, pyramid, cone and torus. Fantastic. So that brings us to the end of this tutorial, and as always, I really hope you've enjoyed doing this one and that you've got some useful information from it and perhaps some ideas that you can incorporate into your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, then please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.